Okay, so what is a surd? A surd is the root of a number that cannot be written as a fraction. So in other words, you cannot get rid of the square root or the cube root sign without it being a decimal that would fill your calculator screen because it's an infinite decimal. In other words, it's known as an irrational number. So when we're simplifying surds, we are going to use factorization, and the important facts that we need to remember about surds are that the square root of any prime number is a surd. The square root of any whole square number is therefore a whole number. And you can see at the right hand side of the screen that there are the squares of the numbers 1 to 10. And if we were to square root 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, we would get back to the whole number that we've squared to get that squared number. The reason we use surds is because it gives us an exact value. So when we're doing things like Pythagoras, instead of having to round to decimal places, we would leave our answer as a surd. So we're going to simplify some surds. We need two factors when we're simplifying surds, and one of those factors must be a squared number. So the first example we've got is to simplify root 20. So if we look down our list of squared numbers, we want to find the highest factor of 20 that is a perfect square. So 1 obviously is a perfect square, but it's not going to actually change our number, so it's not going to simplify it. 4 is a factor of 20, and that's the highest factor of 20 because 9 and 16 are not factors of 20, and then the rest of the numbers that are on the list that we've got at the side are all larger than that. So the way we're going to write this down is we're going to write equals, and we're going to do a square root sign, and underneath it we're going to write the perfect square factor first, which is 4, and that's multiplied by, and in this case it'll be 5 to make our 20. We're then going to split it into two separate roots, and we can get rid of the multiplication sign. And then the final step is to actually square root the perfect square, and we end up with 2 root 5. So let's have a look at the next one. We've got root 48 this time. So we're looking for the biggest factor that is a perfect square. And I would suggest that when you're doing surds questions, you quickly jot down the squared numbers up to the value of what you've got underneath your square root sign. So in this case, 1 is a factor, 4 is also a factor, 9 isn't, but 16 is a factor, and we want to use the biggest factor. So again, we're going to write our equals sign, and we're going to write our square root sign, and underneath it we're going to write 16 multiplied by, and 16 times 3 gives us 48. We're going to write it as two separate roots, getting rid of the multiplication sign, and then we're going to square root that root 16 to give us 4 root 3. Now, what if we don't choose the largest factor? Well, let's have a look and see if we'd chosen the 4. So we'll start with our root 48 again, and this time we're going to choose 4 multiplied by 12. So we're going to write it as root 4 root 12, and we've got 2 root 12. But now we need to double check and make sure that root 12 is in its simplest form, and it's not in its simplest form because it has a perfect square factor of 4 again. So this time we would just have to do an extra step where we're going to split root 12 into root 4 and root 3, and then we're going to have 2 times 2 root 3, and that's going to give us 4 root 3. So you can see we end up with exactly the same answer at the end, but it took us a lot longer to get there if we don't choose the largest factor.